The constraint with node 2. Really, I have nothing new to share with you before you do this activity. It is a node, it has some inflow and it has some outflow, and it is a transshipment node. And I'm sure you already know what the constraint is. Okay, the constraint, you are going to write it in that way. The inflow must equal the outflow. Pause the video and write the constraint for 2. As most probably you have written it correctly, the constraint related to node 2 has 4 variables involved: 1, 2, 2, 3, 3, 2, and 2, 5. And the inflow, that is x12 plus x32, equals x23 and 25. And we can check the answer together, and it is the 1. And after that, since it is very similar to activity 3 and also the ones that we did together before, please write down the constraints related to the nodes 3, 4, 5, and 6. It is exactly the same as what we have had before. Okay, let's do it for node 3. And when we have it for node 3 seems a very busy node. 1, 2, 3, just okay. Node 3, we have 1, 2, 3, 4, 5, 6 variables are involved with node 3, and the constraint is here. So let me select that. Okay, so let's go for the incoming. For the inflow, we have 2, 3. For the inflow, we have 1, 3. That are the inflow that you are seeing them here. 2, 3, and 1, 3. And since they belong to the other side of the equation, because they are sent to the other side, the signs have become minus. And for the other one that are outflow are 3, 2, as you can see here, 3, 4 here, 3, 5 here, and 3, 6. And so similar logic continues for the other nodes, and just make sure you have written all of them correctly before you proceed to the next activity. The next activity goes for the constraint for node 7. Here I have some story to tell you, my friends, about node 7, because now we see we are not covering the constraint regarding node 1. Why it is the case, and it is not similar the previous the previous network models in which for each node we had a constraint. Let me tell you the point. See, the reason that we are writing the constraint related to nodes 1 and 7 together. In fact, for nodes 1 and 7 we have only one constraint. The reason is here. The reason is the objective function that you see. What is the objective function? The objective function is x12, x13 plus x14. So you see the outflow of 1 is considered as the objective function. So that's the thing cause some sort of tiny difference between this type of models and the previous one. So since we have the inflow or outflow of 1 in the objective function, we are not gonna write any other constraint on here independently. Instead, we are gonna write the constraint regarding 1 and 7 together. And you see implicitly, we are now covering this point that 1 and 7 are connected. And it is in fact, oh no, that's okay. That's okay. Let me not confuse you more. Okay, so what we are gonna put is this fact that, let me delete these things so it would be more clear to follow. Okay, now if I ask you, if you remember, we said the inflow of 1 equals to outflow of 7 because they are the entering point of the network and the exiting point of the network. Makes sense. And the inflow of 1 equal to outflow of 1 according to all the examples we have done so far together. Also, the inflow of 7 equals to outflow of 7. And again, the inflow of 1 equals to outflow of 7. So we can write down that the outflow of 1 equals to inflow of 7. Makes sense. The outflow of 1 equals to inflow of 7. Why? Because inflow of 1 equals to outflow of 7. So instead of outflow of 7, I put inflow of 7 because they are similar to each other, they are equal to each other, and inflow of 1 equals to outflow of 1. So I put it over there. What is outflow of 1? Outflow of 1 is 1, 2 plus x, 1, 3 plus x, 1, 4. That is equal to inflow of 7, that is x 5, 7 plus x 6, 7. Remember, my friends, there is nothing to memorize. It is just common sense. Make sure you have a good understanding of all these points with the same logic that I described for you to come up with this formulation, with this equation that you see here. You should get it written on your paper in front of you, and it is the constraints. Let's remove this and bring it over there so we can compare them better to see they are very the same. So here we have, as you can see, x12, x12, x13, x13, x14, x14, and also the other side x57 and x67. And with this constraint being written, now we are ready for the next phase. So if you think you are not caught up and you need more thinking, contemplation on the problem, just pause your video and check it. And if you have any question, immediately forward your question to me. But now we are going to also consider some other constraints in this problem. And as you can see in the slide, for the first time, additional constraints are needed to enforce the capacity on the arcs. Because so far, when we use the numbers on the arcs, all of them were related to the objective function. When it was transportation model, it was the cost. When it was assignment, it was days. When it was shortest route, it was distance. So you see all of them were directly related to the objective function. So we didn't put them in the constraint part, but for this problem it is a little bit different because it is some sort of constraint. It talks about the capacity of each road, so we need to consider them as constraint, and the constraints related to them is super easy, my friends, and very easily you can handle them. It is asking you as activity 6, what is the constraint of arc 1, 2? Okay, you need to write the constraint that is related to arc 1, 2. It says the capacity of arc 1, 2 is 5,000 vehicles per hour. So when you want to write the constraint, you need to be careful that x2, the traffic load that is being put on arc 1, 2 must be what? Pause the video, think about it before you check the answer on the next slide. Okay, x12 equal or smaller than 5. It means that you cannot make x12 6, 7, 8 because the capacity of the road is 5. So the load that you put over it must be equal or smaller than 5. After that, it asks you about the constraints of arcs 1, 3 and 1, 4. Very similar to the previous one. The constraint related to arcs 1, 3 and 1, 4 is very similar to the previous ones. Okay, 1, 3, it says that the capacity is 6, and for 1, 4, it says the capacity is 5. So the amount of traffic load that you put on each arc must be equal or smaller than the capacity. Let's check the answer. x13, it says equal or smaller than 6, and x136, as you can see, and x14 equal or smaller than 5. And the other activity that we have, it says that what are the constraints for the rest of the arc. So you need to check all the decision variables that you have and write the constraint for each of them, and all of them are the same. For example, when you want to write the constraint related to x25 here, x25 equal or smaller than 3, or x57 equal or smaller than 8, x46 equal or smaller than 5. Just make sure you are not missing any of the variables and you are writing all of them. Okay, the answer would be this. And now we have all the decision variables with their associated capacities, and after that you get it done. The last constraint that we are going to cover is the non-negativity constraint, that it is a very easy one, and xij must be equal or greater than 0 for all of I and j's. Now, my friends, you have modeled this problem, this maximal flow problem. It means the model that you have gonna solve the mathematical model, the challenge, and gives you the maximum capacity that this network of roads can handle. While, for example, 1, 2 has the capacity of 5, or 3, 6 has the capacity of 7. And for example, another things are 1, 3 is connected to 3, 5, and all the things being considered, and finally it tells you what is the maximum capacity of this network and which roads must be taken and which roads must be get off, and the roads that are taken on, what would be the assigned traffic load to them. Okay, in the next part we are gonna solve this problem and see the results.